ideas, the most immediately useful was a notion of light as a kind of ray, which shot out from the eye. Over the last 2.5 millennia, this notion of light rays has been refined into the study of optics. Optics explains little about what light is, but from the earliest times has provided great practical insight into how light behaves. Generations of comic book readers have imagined superheroes who can project X-rays from their eyes. These rays can actually penetrate walls and catch unsuspecting bad guys as they sneak about their life of crime. The idea of rays is embedded in our minds and in the lives of all of us. For that we have to thank the ancient Greek mathematician Euclid, who in 300 BC went one better than the superheroes and proposed that light itself is a ray which streaks outwards from the eye. The eye ray idea was not new at that time, but Euclid brought mathematics into play by proposing that these light rays are not fixed curves or wobbling changing lines, but the shortest distance between 2 points, a straight line. Euclid was interested in supporting the exploration of light by using his new mathematics, geometry, which is based upon regular shapes, and in particular upon straight lines and the angles that are formed when straight lines meet. The ancient Greeks were limited in their ability to test theories by experimentation and observation. If Euclid had proposed that light shoots out in straight lines from sources like the sun, he might have accepted that the crisp shadows cast by the sun are evidence of the straight line behavior of light rays. But Euclid's idea had no such support because his light rays streaked from the eyeball. Nevertheless, Euclid's geometry seems to suggest some answers about how we actually see a number of different things. For example, light rays streaking from the eye sweep from the top to bottom of a shape. Rays striking the extremes of the shape form a particular angle. When an identical shape is moved to a greater distance, light rays touching its extremities form a smaller angle. Without any explanation of what a light ray actually is, or how they actually form an image in the eye, Euclid's ideas nevertheless seem to offer some explanation of why distant objects appear smaller than closer ones. Optica was the name of Euclid's work, rooted in the Greek word optikos, relating to vision and sight. Optikos is in turn the root of the modern word optics. This study of light waves using geometry has proved consistently useful over the centuries. Gradually, it became accepted that the same geometry that describes how light rays might leave the eye can also be used to describe how light behaves as we now understand it to do so, leaving light sources such as the sun or a flame, reflecting from objects and eventually reaching the eye. In spite of the usefulness of light rays, whether from an eye or from a light source, they describe a pathway for light rather than describing light itself. A particle theory of light does describe light itself. This idea had strong support at the beginning of our modern scientific era in 17th century Europe. Light particles, emitted from bright objects, strike and reflect from other objects, some eventually reaching our eyes. Geometric optics and the study of light rays actually supports this particle theory of light, because particles could be imagined to travel in paths, described by the straight-line geometry of light rays. A second idea about the nature of light evolved from ideas of an ether that exists everywhere, even outer space. As proposed by the Greek philosopher Aristotle, light is a disturbance in this invisible ether. By the 17th century, a new mathematics, Cartesian geometry, allowed space to be divided in a grid system upon which mathematical expressions could be plotted, like this one, which can in 3 dimensions create a regular wave-like pattern. Aristotle's vague disturbances in the ether were now seen as something more organized and predictable, sets of mathematically defined sine waves, which propagate outwards from light sources to strike objects and reflect from them, bringing information about colors and textures to eventually reach the eye. Once again, light rays can support this theory by describing the direction of propagation as a ray or set of rays stretching out from a point source of light. Further from the source of propagation, these waves become, to all intents and purposes, parallel to each other. Light rays could be imagined as the direction of propagation at right angles to these parallel waves. Over the last few centuries, our ideas about the nature of light have become more sophisticated. We now think of light as a kind of energy or electromagnetic wave. And we also think of light as a kind of energy particle, a photon. In spite of these refinements, the light ray conceived by Euclid, as well as the entire study of geometric optics, remains useful and important to the present day, because it continues to provide us with effective tools for predicting, exploring, and using the pathways of light.